Okay, this goes with the lesson on reviewing solving two-step equations. And we're going to throw in a little bit of equations to fit the situation. This is still review, so it's been a little while, but this is so important as we move into algebra. All the stuff that we're working on this unit, it's kind of your bread and butter from now until eternity. As long as you are taking a math class, what we're doing right now is so important. So let's remember the goal. I hope you guys remember when we did this in the classroom. We did a little activity that we played until someone exited the classroom. The goal is to, starts with an I, isolate the variable. The equation isn't solved until you isolate the variable. This is also called solving for the variable. Okay, remember that an equation is going to have an equal sign. So we just went through this really long review with expressions and kind of craziness there. And now what we're going to do is we're going to put this equal sign here and set either two expressions equal to each other, an expression equal to a constant. So the first thing that I'm kind of going to go through the list of what we're going to look for. The first thing we're going to look for in this goal of isolating the variable is adding the opposite. And as I've talked about before, this is if needed. I mean, if you're faced with 10 minus 4, strategically speaking, I don't need to go, oh, 10 minus 4, I'm going to add the opposite 10 plus negative 4. No, I know what 10 minus 4 is. It's 6. So be strategic. The real reason when we need that is when we're distributing that negative term. Sometimes if it's just easier to do that, even if I'm distributing a positive term, I might like adding the opposite here so that when I distribute that 2, I just get that plus negative 6 rather than 2x minus 6. This is just personal preference. They're equivalent expressions, so it's if needed. That's kind of discretionary, and you get better at it as you see it more often. So if you see distributive property, typically adding the opposite is needed to distributive property. If it's there. We use the distributive property in order to eliminate parentheses when we have variables. If I have 5 times the quantity 10 minus 3, well, I don't really need to solve this with the distributive property. I can order of operations this. I mean, could I solve it with the distributive property? Absolutely. I'm still going to get 35. Where we have to pump the brakes is now we're going to be using variables. 5 times the quantity, x minus 3, and I don't know what x is. I can't say what x minus 3 is. The only way to eliminate those parentheses is to use that distributive property and kind of distribute that factor of 5x minus 15. Again, I chose not to add the opposite here. I didn't feel like I needed it. You absolutely could. You'd get 5x plus negative 15. Either one is fine, but that's how we're going to eliminate parentheses. The third thing we're going to look to do is combine like terms. Now, the caveat on this with combining like terms is we're going to combine all the like terms first on the right side of the equal sign, and then on the left side of the equal sign. We do not cross the equal sign yet. So what that's going to look like is if I had 3x minus 4 plus 2x equals 15 plus 17. So looking at that equation, I've got an expression over here, and I've got an expression over here, and I can do some combining like terms. So this is all going back to the review that we did the last couple of days. So here on the left, sometimes people think about that equal sign as a wall. So we're on the left-hand side of the wall. We're just looking to combine like terms here. So I can add the opposite here. I have a 3x and a 2x, 5x plus negative 4 equals. And over here on the right, and again, I'm not crossing the equal sign. I'm just going to look at it as 15 plus 17. It's going to be 32. Now, I can't combine any terms. I've got a variable term, a constant term on the left-hand side, and a constant term on the right-hand side. Now I'm ready to balance the equation. This is where we're going to use those inverse operations. And this is that golden rule of mathematics. What you do to one side, do to one side of the equation, you must do to the other. This is a rule that just keeps getting added to and becomes more and more and more and more and more complicated as we move on through math, but the idea remains the same. We are going to show our work. We are going to work vertically. Typically, the first thing we're going to do is add or subtract to both sides. And the last thing we're going to do is either multiply or divide using the coefficient. Ultimately, we want to get all of our, it's that ax equals b. We want to get all the variable terms over here, where a is that coefficient. We want to get all our constant terms over here, or b equals ax. It doesn't matter. And then the final step is to take that coefficient, either multiply or divide there. Let's look at an example. Now, you guys have a great practice sheet that's on there for solving equations. One of the ones on there is just 3x minus 2 equals 32. This is super simple in review. It's always nice to start with stuff we've seen before. We can't combine terms. We don't need to add the opposite. We don't have the distributive property. This is truly that ax plus b equals c form that we've seen so many times before. I'm going to add 2 to both sides, and I want you guys to continue to show this work. You're going to draw a long equals line across. You don't have to draw that long line down here if you don't want to. You bring down that equal sign. I want it to line up vertically. Subtracting 2 and adding 2, that is 0, so that leaves us with 3x minus 0. I don't need to write minus 0 there. All I got to do is write 3x. 32 plus 2 is 34. Now I've got that ax equals b over here. So now I'm going to just divide by 3 because this is multiplication. My inverse operation is division. Divide by 3. 3 divided by 3 gives me that beautiful coefficient of 1. 34 divided by 3, that's a little messy. Let me think about that. 10 would give me 30, so I could get 11 out of there. 11 whole 3s and 1/3 remaining. If you were using a calculator, I would certainly accept. But you got to have the repetent there. Without the repetent, it is wrong. They're not all going to be beautiful, gorgeous answers. Some of them may be negative, some may be fractions, but you can practice simplifying as well. That's all it is right there. If you're looking to do the check step, this one's a little messy. You take your answer. You substitute it back into here. So I had 3x minus 2 equals 32. I'm only changing this into 11 1/3, which I'm going to keep as 34/3. That's kind of skipping back a step here. Strategically, it allows me to start moving forward right away. Wow. Okay, so when I'm multiplying, I know how to cross simplify, but I'm not going to do that because we haven't really technically discussed that. 34 times 3. Let's see if I can get it right. That's 12. 102 divided by 3 minus 2. So 102 divided by 3. Oh man, I'm getting old. That's a 9. 34. 34 minus 2 is 32. That's going to give me a true statement, meaning that number of 11 1/3 I found there is correct. The other part, the other worksheet that you're going to see, that one kind of looks like this, but that's the answer key. The other one you're going to look at from this video is going to be this first page in a geometry book, and the green and famous from running away from jail. That is one of my favorite riddles of all time. This is one of those worksheets where it's really going to be asking you, here, let me find one that's blank. I wrote it over here on the side. You must write the equation that fits the situation. So all of these are probably going to be two-step equations. You got to get in there. You got to think about that ax plus b equals c format. Ken is thinking of a number. Is this Ken and Barbie? Oh, who wrote this? All right, none of the answer keys give away the riddles, but this green and famous for running over jail is a good one. Good for the Thanksgiving table. 9 more than the product of 4 and the number is 73. Is always means equal. I know this equals 73. 9 more than the product of 4 and the number. So 9 plus 4x equals 73. That's the equation to fit the situation. Subtracting 9 from both sides, 4x equals, is that 64? 64? I don't know. Let me look at my answer key. I'm feeling unconfident in this one. I hope I subtracted that correctly. I'm sure you guys will correct me if I'm wrong. X equals 16. And then you can move on from there. But really practice writing that equation. That's really, really good stuff. That's it for this video. Good luck, and I will check in with you guys.